All right, here we go. Our objective for today, I can add and subtract real numbers. Read together, 1, 2, 3. I can add and subtract real numbers. So where does that go on your Cornell note? And the objective at the bottom left, bottom left. Copy that, please. All right. So according to the questions, it says, what is the concept for today and what are we doing with it? So share with your neighbor the concept for today. Concept for today. Okay. Concept for today is real numbers. That is correct. And what are we doing with real numbers? Adding, subtracting. Now, so that you have like a little roadmap as to what we're doing, there are 4 basic arithmetic operations. We have addition, subtraction, multiplication, and division, right? So today we're doing what? Addition and, so what do you think we're doing tomorrow? Multiplication and division, right? And with every concept, big concept that we arrive to, we're usually going to be doing those 4 things, okay? So, with that said, what goes in your Freyer model, in the center of your Freyer model? What would you write? Real numbers. Write that in there, please. Real numbers. Real numbers. Definition. The set of all numbers that can be represented on the real number line. Real numbers. The set of all numbers that can be represented on the real number line. Real numbers. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. Real numbers. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. Tell your neighbor the definition for real numbers, please. Good. Examples. Write these down. 2/3, 7.25, 23, Michael Jordan, -8, pi, square root of 2. And then last week we had started with the whole numbers, which are the counting numbers, including 0, and then integers, which include the opposites. Okay, copy that. All right, let's see. I'm going to go over the definition with these examples, and then we'll elaborate a little bit more. Writing utensils down, please. Eyes up here. Here we go. It says, the set of all numbers, which means a group of all numbers that can be represented on the real number line. Okay? So last week I had you write sketch a number line, right? From this point forward, anytime I ask you to sketch a number line, we're going to call that number line the real number line. That's what we're going to be dealing with this year, real number line. Therefore, look at this real number line right here. Would you be able to plot 2/3 somewhere on the number line? Yes. How about 7.25? Yes. How about 23? Yes. -8? How about pi? Yes, where's pi at? 3 point something, right? So about right here. How about square root of 2? Let's see, what is square root of 1? 1 times 1 is 1, so 1. What is square root of 4? 2. So this is in between 1, and 2. So square root of 2 somewhere right here. Okay. Are we there so far? So now, right now when I asked that question, I had some of you kind of like hesitate. I sensed a disturbance in the force. So here goes square root. So look up to the screen, please. Square root. Square root means what number times itself. Let me repeat that again. What number times itself would give me the number that we're trying to find the square root for? Everybody understand? So let's see. If I was to give you and ask, what is the square root of 16? Question, is this a real number? Talk it over with your neighbor and see where would this one go on the number line. Go. All right, we're ready? Let's see. Leslie. Yeah. Is that a real number? Yes? Why? It says because you can represent a real number line, so where would it go if it is a real number? Close, because this is a square root. So this represents another number, not greater than 15. What number does it represent? Volunteer. Yeah. That would be correct if I was dividing, but this is not division. This is square root. What was the rule? A number times itself. What is that number? 4. So therefore, see what I did there? I can plot it right about here. So let's see. What is 4 times 4? 16. Okay. Is that the only number multiplied times itself that gives me 16? Tell your neighbor the other number that multiplied times itself gives us 16. Leslie, pick someone. Paulina, what would be the other number times itself that gives us 16? Hands if you got it. How about -4 times -4? What? What is negative times a negative? 4 times 4 is 16. So -4 would be over here. Therefore, see what I did there? Is this a real number? Yes, so write it in here. Square root of 16. And we're going to get more into radicals later on. But for the purpose of introducing real numbers, that's enough. All right. Everybody with me so far? Okay. Here goes another number. Is this a real number? Talk it over with your neighbor and let them know if this is a real number and why or why not. Okay? Let's see. Kylene, is this a real number? Yes. So what number times itself gives us -16? Yeah. 4 times 4 is 16. Because the rule is a number times itself. Did anybody find the number? What number times itself give us -16? Now, I heard you say -4 times 4, but is this the same number? No, it has to be times itself. Is there such a thing? No. So what can we conclude about this number? It's not real, so where does it go? So write that in here, negative 16. So, if these are real numbers, what do we call this one? What shall we call that one? Tell your neighbor. Let's come up with a name. Tell your neighbor, what can we call that one? Let's see. Emily, what would we call these if these are not real? That is correct. Imaginary. That is correct, yes. These are known as, and a way to remember, check this out, look up. Who can remember this? Yes, these are imaginary numbers. Write it in there, please. And when you get to Algebra 2, instead of calling them just imaginary, they're going to call them complex numbers, complex. And there is such a thing. There's a line, a number line that's called imaginary line, okay? So, we understand what real numbers are and what they are not, yes? So, talk it over with your neighbor. What would be a hashtag that you would add to this that explains what real numbers are? Hashtag what? Talk it over with your neighbor. Hashtag what? Jesse, go. What is it? What? Hashtag what? Okay, remember, these are what make the concept. Hashtag real. Whoa. Woo. That's a good one. Another one. Pass it to someone. Leslie? Hashtag what? What would you send as a hashtag for real numbers? They need to have what? Bam! Not imaginary. Does everyone have more? Anything else that we can add to that? We go with those two? Anything else you want to add? So real, not imaginary. Wow. Yes. Hashtag real numbers. Okay. And if you have another one, just add it into your critical attributes. All right, we good? Okay. Let's move on. Underneath your FAIR model, I want you to write steps, and I'm going to give you steps to follow for today and tomorrow. And it says, to add and subtract real numbers, I add the opposite of the second to the first. Represent each number on the number line with tiles, symbols, and ground zero. Identify all zero pairs and use absolute values to add. And number 4, simplify. Copy those 4 steps, please. On your screen, I put a quick review of what we saw in regards to the additive inverse property. You guys see that? And I did the introduction and I did the animation using that slide where I showed you how to represent the additive inverse property using the ground zero. That's what we call the ground zero, right? That's one of the ways that we're going to use in adding and subtracting real numbers, okay? The other way or method. Last year, who remembers using the number line to add and subtract? Your teacher showed you guys using the number line? Yeah, right? The third way was using tiles. Have we started using tiles since last week? Yes, Mr. Q, we love them. Good. And this week, I just want to put them all together, and right now I'm going to do a quick review of the absolute value rule. Let's see if you remember. Here it goes. It's on your screen. You guys see it? Here it goes. Absolute value. The absolute value rule works as follows. Take the absolute value of both numbers. So absolute value of 3 is 3. Absolute value of 6 is 6. If they're the same sign, you add these two and you keep the sign of both numbers. So 6 plus 3 is 9. They're both positive, and that's why we get 9. Here goes again. Absolute value of negative 2 is 2. Absolute value of negative 9 is 9. Are these the same sign? Yes, so we add and we keep the sign. Both of them are negative, so 2 plus 9, that's 11, so it becomes negative 11. Are we there so far? Okay. Let's go over the bottom ones. Absolute value of negative 8 is 8. Absolute value of 12 is 12. Are these the same sign? No, so we subtract now. So what is 12 minus 8? 4. And what is the greatest absolute value of 12? What is the sign of that one? A positive. There it is. Let me do that again over here. Absolute value of 3 is 3. Absolute value of negative 15 is 15. They're not the same sign, so I'll subtract 15 minus 3, that's 12. And the greatest absolute value was a negative, so this is negative 12. And that's how you use the absolute value. Are we there so far? Okay, so what we're going to do, we're going to add and subtract using 4 different methods. Okay, so turn your paper over. And I want you to write example 1. Example 1. Add 4 ways. Example 1. Add 4 ways, negative 3 plus 7. Negative 3 plus 7. So once you copy that, you're going to draw a line down like so, a line across like so. And now we have 4 quadrants for all 4 different ways, okay? So let's start with the first way. What did we start doing last week? What did we start using? Tiles. So therefore, we start with how many tiles? Negative 3. 1, 2, 3. How many positive? 7. 1, 2, 3, 4, 5, 6, 7. Circle your 0 pair, and we're left with positive 4. Over to the right, I'm going to go and I'm going to use ground 0. Draw your line. Here's ground 0. So what is my first number? Negative 3. So how deep is the hole? 3 feet. Negative 3. How much dirt do I have outside? Positive 7. So question, is this dirt going to fit in here? No, only part of it, right? But will it cover the hole? Yes, the hole will be covered, but we're only going to use about this much. Fits in there. So how much do we have left here? Positive 4. All right. Let's go to the bottom left. Using the number line. I want you to draw a number line. And we're always starting from 0. For negative, I'm going to use red. For positive, I'm going to use green. So here we go. My first number is negative 3, which means from 0 I go to the what? To negative 3 to the left, right? 1, 2, 3. From there, the next one tells me 7 steps to the right. But where am I at right now? At negative 3. So then I go 1, 2, 3, 4, 5, 6, 7. Let's see where did I land. Here's 0. Here's 1, 2, 3. I'm at positive 4. So far, so good? And the last method, using the absolute value. All right, let's write it in there. Let's write negative 3 plus 7, and let's use the absolute value. What is absolute value of negative 3? Absolute value of negative 3 is 3. Absolute value of 7, 7. Are they the same sign? No, they're opposite signs, so we subtract 7 minus 3, that's 4. And which is the greatest absolute value? 7, it's positive, so this stays positive, and that's our 4 methods. So first one using tiles, ground zero, number line, and absolute value. How are we feeling? Okay? Okay. 1 being the lowest, 5 being the highest. How comfortable do you feel with these? 1 being the lowest, 5 being the highest. How comfortable do you feel with these so far? I see some 5s, some 2s, 4s, 5s, 3s, 4s. Okay? Do this next one by yourself. See how you do with this one. Example number 2. It says, example number 2, add 4 ways, negative 4 plus negative 5. Copy that and go. Look at example 3. Copy that, please. Negative 5 sixths plus 3 sixths. There you go. Draw a line down, line across. So for these, we're going to create unit circles. Unit circle for the first one, and unit circle for the second fraction. And we need to divide these circles into how many portions? 6. So you draw an X, and then 1 through the center, an X, and 1 through the center. And for the negative ones, just label the ones that are going to be negatives. How many negatives? 5, 1, 2, 3, 4, 5. How many positives? 3, 1, 2, 3. Okay. And then from there, let's cancel out the ones that are going to cancel out because of the 0 pairs. This one with this one, this one with this one, this one with this one. And what does that leave us? Negative 2. Negative 2 what? Sixes. So negative 2 sixes. Can we reduce that? Yes, negative 1/3. I'll stop right there because you need to copy the home plate. But the number line, you need to do a unit for 1 and a negative 1. So for home plates, only 8 problems. There they are. Go ahead and log out of the Nearpod as soon as you copy your home plate. Enjoy your home plate tonight, and we'll discuss this tomorrow. Tomorrow we're going to get to a work problem that we didn't get to, so that'll be it for today. Have a good one, guys. As soon as you copy that, see you guys tomorrow. Bye.